Okay, restarting because last time was too long. Here's problem one. There's the end result. It's the weird star shape thing. Essentially, all that I did was add 4 new verts, increase the number of verts being multiplied by the size, and then I had to juggle around the index buffer, I guess, organization so I could properly write out in the counterclockwise fashion. Again, multiplying by the number of triangles since it'd be 6, since it's 4 new triangles added on top of the square, which is made of 2. The draw scene, again, multiplied by 6 for the complete number of triangles. And then that's pretty much it for number 1. So hard-coded. Number 2, here is the constant int of numbers, and then here's ratio, and as I've written here, this represents the number of triangles needed to create the n-gon. And then I have 2 functions of create n-gon and create index b. Those are defined at the very bottom as basically for loops to populate those 2 arrays. For create n-gon, it's basically get the proper vertice and angle, or vertice positions such that any n-sided polygon would look as close as possible to a circle. So triangle, if it's 3, then it'd look like a triangle, and so on and so forth. And then create index b is to keep the specific triangle formation provided in the demo, um, such that it has the pattern of 0, 1, 2, 0, 2, 3, 0, 3, 4, so on and so forth. And how is that showing? Here, I will quickly run it back into 12 to show that it works there. Let me first stop it. And then if I could make it there, are you there? I'll also switch it back from wireframe to solid. Play real quick. And while that's running, essentially the only changes made to the, I guess, uh, properly sizing to the memory is for vertices, it's multiplying by the number of verts. For the indices, it's multiplying by the ratio to get the proper number of triangles. And then again, in the draw, it's doing the exact same calculation to get the number of triangles correctly. And then, as for the further questions for number 1, as for the first part, changing the top vector to 1, it's the same triangle because the NDC's current range is 0 to 1, so it's still within range, meaning it won't get called further down the pipeline. But when changed to 2, it becomes a trapezoid because it's past the range of the NDC, meaning during the clipping stage and the rasterizing stage, it trims the triangle accordingly and then backface calls it. And then again, when the bottom right is set to 2, or the z value is set to 2, once it gets to that part of the stage again, it trims it off and then backface calls it accordingly. As for number 2, the indirect 3D, messing around with the top left values moves where the window, I guess, begins. Not really begins, but like where it starts to render what you're trying to project out. So let's say you have a triangle in the middle of your screen. You increase it by 300 or like 250 and 250. It'll be moving down or moving up to the right by that many pixels. And as for why this would be useful, well, it could be used for testing proper, I guess, culling to make sure that the engine's actually properly destroying said model, or to specifically change it to, um, I guess, new uh, screen resolutions or display resolutions. So Like if you're moving it from a high resolution computer to a low resolution mobile device, then I guess you could use that to properly emulate it, more or less. And then the last bit are the two DXGI formats. The first one, the RGBA 8 UNorm. In plain language, that's an enumeration of 28, and then the other one, the red 16 unit, is an enumeration of 57. And UNorm and UInt and SInt all basically stand for the formatting of that specific component. So UNorm is unsigned normalized integer format, UInt is unsigned integer format, and SInt is signed integer format. And with the UNorm one, since it what basically is being used that is during the buffer description. So it's setting up 8 bits of the 32-bit count specifically for supporting each RGB channel, including alpha. And then the R16 one is being used in the, I could actually scroll down to it here. It's being used here in, what is this? This is the init demo, so this is specifically not the vertex, but the index buffer. So essentially here what it's being used for, or what I think it's being used for, is, well, of course it's red support, and the actual color of the triangle that we're using is yellow, and one component of that is red, so that is needed within the actual buffer to, I guess, create said color. But yeah, that is about it. Yeah.